Okay, so welcome everybody. Today we're going to start with a talk from Mario, who's invested some effort to put together sort of an overview of the sort of state of the art or the state of thinking regarding contact tracing in various places. So I guess I'll pass to Mario.
Thanks, Peter. So I actually wish I could have invested more time, but I was seriously pressed due to other things. So those are a couple of slides that are really just a summary of what is going on. And I have put links to all the details wherever necessary. So the first question, of course, was why are we doing this tracing? And the idea is that we want to significantly reduce the time that it takes to communicate whenever someone is infected, because a person can be contagious without them knowing. So if we can stop this as early as possible, that would be very helpful. So if we can figure out the persons who don't show symptoms yet, notify them, then we can preemptively quarantine these persons so we break the chain of infection. So the hope is that with this, eventually we can reduce the duration of widespread lockdowns. I have linked two things here. The first one is a video by Armin Ronacher. This is an introduction on the whole idea of contact tracing. It goes for 20 minutes or so. I highly recommend that you watch this video. And if you only have 2 minutes, then I suggest you have a look at the comic from Nicky Case, who did a very nice job to break it down. So this tracing is typically done by health officials and sometimes even with some legal leverage behind it. So it might be that you have people knocking at your door. This means this is very tedious and very manual, and most likely endangers also the health of the person who is doing the tracing, and eventually, if not done properly, potentially spreads the infection by having the tracer person going from door to door. So while effective, it can be really another vector of infection as well. The first country in the recent outbreak that did it a bit different was Singapore, because they started by doing digital tracing by using the smartphones of the people living in Singapore. And if you have a look at the plot to the right, you can see that the numbers are really impressive compared to all the other countries in the world. And there's a couple of papers on epidemic control with a link to the paper from Ferretti. And you can see that this is a really excellent approach to deal with these infectious vectors. So there have been a couple of countries who have, which have deployed these tracing apps. And the first one was obviously Singapore, and their app was called Trace Together. And they actually opened the protocol of this application, and they called it Blue Trace and then later Open Trace. So you can actually go to GitHub and look at the protocol. The second country to introduce that was China, and they made it mandatory. So whereas in Singapore it was an opt-in, China practically forced everyone to use this. And the way they did it, they have these two very widespread applications in China called Alipay and WeChat Pay. Those are proprietary applications. And of course you get the expected privacy concerns that go along with that. Then Australia and New Zealand were rumored to build their applications on top of the Singapore protocol, but eventually came up with their own custom proprietary solution. In the meantime, the Red Cross in Austria came up with their own proprietary implementation, and the same problem as in China. It is not possible to look at the source code unless you are belong to a very selected round of people. right next door, the Czech Republic, they created an app that is public on GitHub, Irushka, so the electronic face mask. And this one was integrated into the Czech system for the smart quarantine system. So they did it as part of their overall effort. Another interesting one came from Israel, their Shield app. And that one is particularly interesting because it has location awareness of the data, whereas all the other ones just do contact tracing and you wouldn't know where the contact happened. And this one is also open on GitHub. And Russia took a different approach. They did a geofencing app. So if you are confirmed infected, then you have to run this app and it will practically track you, and they will make sure that you don't leave your quarantine. There's this link underneath. If you click there, there's roughly 20, 25 different apps, all of them different variants of those. There's also different types of apps that were developed that are not for tracing. Those were mostly for self-diagnosis. So you could, there's some flow charts and questionnaires that you would go through, and it would check if you have this symptom or that symptom, and then it would recommend you what to do, if you should go to the emergency room, if you should contact a care worker or a hospital, those kinds of things. So this is practically what is out there right now. And all of this has been put together in sort of frameworks. And the first one I already mentioned, there was Blue Trace and now Open Trace. The interesting part about this one is that it needs a central authority. So you need to have a government or a company that needs to run this service. The alternative is a decentralized approach that is built upon the idea of temporary contact numbers. And there is this TCN coalition and has the original white paper for this. So this is a decentralized protocol where it's practically difficult to figure out the global state of the system. Based on this, several improvements have been proposed. And the first one that did so was the contact event numbers, which has hardened versions of these TCN principles. So these protocols go through different phases: broadcasting, reporting, and scanning. And depending on which type of cryptographic method you use, you can harden these steps in the protocol. And this one, the CEN protocol, is US-centric through COVID Watch and Co-API. So this is Stanford and Seattle. And at the same time, in Europe, there was a similar approach to come up with a hardened version of the TCN protocol. And what happened was that a coordination initiative was founded, the PEPP-PT, which just serves as a governing body, so to say, while not having any legal binding. It's just a group of organizations that decided it would be good to work on this. And they take care of testing of applications, integrating the apps with the health officials, dealing with the governments, those kinds of things. And what happened was that institutes were submitting TCN improved protocols to the PEPP-PT, and the one that came out of it was the DP3T, so which is practically works in the same way as the CEN protocol. So it has hardened versions of the broadcast report and the scan phase. And while practically the same, they differ in tiny little things that are cryptographically interesting or important and focus on different things. It is very likely that the DP3T will become the reference implementation that will be recommended by PEPP-PT.
See, Mario?
Yes.
Can you explain what you mean by hardened?
Hardened?
Yeah.
Hardened means that you put a cryptographic mechanism on top of a communication protocol or data mangling protocol. This means that you have an attack vector. For example, you want to move a message from A to B, and you want to make sure that the attack vector is that nobody else can listen to the channel. Another attack vector could be that nobody modifies the data. And when you harden these paths, it means you use a particular type of cryptographic mechanism to ensure that this attack vector is disabled.
Thank you.
Okay, then there are two more. One of them comes from MIT. This one is interesting because it puts GPS into the game. So the focus of this protocol variant is on location-based gathering of data. And it builds on the private kit that was built by MIT. And then just a few days ago, there was a joint proposal from Google and Apple on contact tracing. And the very interesting part here is that this proposal is based on an early iteration of DP3T. And this makes it particularly problematic because there were substantial improvements in the hardening mechanisms since that early version. So the DP3T authors are now strongly recommending Google and Apple to upgrade their proposal to the newest version of that. One thing that comes with that proposal is that right now it's practically impossible to run these apps in the background on iOS hardware because iOS restricts the use of Bluetooth low energy applications. So you have to have the app running in the foreground, which is kind of a bother. So we expect that through this joint proposal, both companies will open up APIs to their operating system so that this can be done more openly in the future. So, but still, now we have these protocols. What can go wrong with them? As an example, there was the security analysis on DP3T that showed a glaring flaw in the TCN-like approaches. And this one is that because it's an open protocol, everyone can develop an adversary app which can exploit Bluetooth flows. And there are quite a few of them, even if it's just a matter of buffer overflows in the operating system that runs the Bluetooth stack. And this leads to an adversary app that can potentially gather more data from the contacts than the contact actually wanted to share. And the way to mitigate this is through a hardware-based solution called the Trusted Platform Module, where you practically have a trusted third party that puts a key that you have to put into every single device. And then this becomes a trusted device. So if you have an adversary app, it won't be possible for this one to communicate with the other one. So this becomes a clear deployment challenge. And with that, a couple of different problems. So do we have an authority that keeps the master key? Do we trust that authority? Can we even protect the master key? What if there are insiders? And what do we do with the multitude of electronic devices that don't even have TPM chips? So this is one of these problems. On the other hand, those are the same problems that plague the centralized approach. So those are things we have to put on a balance and see which one are more useful for the average citizen. Then there's other things. There's a couple of flaws that are inherent to the protocol itself, because you can do replay attacks, you can do timing attacks or coercion attacks. This practically means that you can force the contact of other devices even though they didn't want to. And the way you do this cryptographically is by mechanisms that counter these timing processes. However, this boils down to delaying notifications. So you can't do this anymore, which goes against the objective of the application, because you want to notify people as quickly as possible. So there are things that have to be addressed by the cryptographers in that area. So the way that a couple of people see a future variant of this is an evolved combined version of the CN and DB3T protocol that addresses many of these attacks, and maybe there's a way to get the key distribution working without a TPM. This most likely will fail at the Bluetooth because the Bluetooth payload is very limited. So there's things to do. And of course, the hope is then this will all run on this new dedicated OS API, so you don't have to have the app running in the foreground. And finally, some words of warning from a couple of institutions. The first one that I found was really interesting was that a privacy institution in Austria called AG Daten, they said that the underlying technological assumption is flawed because Bluetooth low energy cannot be precise enough for what is needed. Because imagine you're sitting in your apartment in Paris, you have 10 square meters and your Bluetooth contact traces the apartment across the street. And those kinds of things. Then the second one is, that one was very interesting, that came from an NGO, that the most at-risk population are typically not the ones who are heavy mobile electronic users, which means the senior citizens are typically not the ones who have the modern phones required to have these contact tracing enabled all the time. And finally, there's the sustainable data privacy that is touched by so many groups right now. And I want to go through them in detail because there are a few very interesting ones. The first one is that you can inject false positives into the system, which means if you have an adversary that wants to eliminate a political opponent, that it's very easy with these systems to inject a false positive and potentially take that opponent out of the game for 2 weeks or even longer, depending. Then you can have behavioral profiling and compliance scoring, which means if you have a particular group of people that is under surveillance or supervision or whatever, what you can do is you can target their contacts directly and practically use this for second order investigations, which means maybe if one of these persons is currently in front of a court for some investigation, and this basically boils down to having to collecting lists of people. And this goes with the third point, which is that it's easily, that additional metadata about the contacts is easily obtainable. And with that, it makes it possible to de-anonymize the patients. And this goes together with all the other ones. So as soon as you know a single person, you have the behavioral profiles, and then you can quickly identify a whole group of persons.
Mario, can you give examples?
So imagine you are a nurse at a hospital. You have a person coming to you and you sign off in the app that now you that you want to notify other ones because you have a positive infection. Now, if that nurse is an adversary, it knows when this happened. And with that, now you have the list of contacts that is known to the hospital and thus to the nurse to spread this information in whatever way necessary. And this can be wherever. So everywhere you have a potential to collect this additional metadata, you open up this possibility.
Like for example, an appointment calendar. Or,
Yes, yes. So the fourth point, that there are actually no legal incentives for the companies who write these applications or run the services to comply with any data retention. So they can say, okay, you have to use this application now and we will delete the data after 14 days. But even within the GDPR, it's not quite clear that they're actually compelled to do that. And this needs to be looked at by the respective courts and legal professionals. Another approach, if you think of more oppressive regimes, if you want to force your citizens to have these apps, and a person says, no, I don't want to do that, you can start to restrict their personal freedoms and say, if you don't install the app and let me survey you, then I will put you in prison or other things. Then, of course, there is no guarantee that all this data will not be used for commercial tracking or selling of the proximity data for other reasons. I already mentioned the secondary investigations. And one of the things that is also interesting that came up in the Amnesty report was that you could do widespread injection of false positives, which means if you want to quickly take down, if you want to quickly take down a group of people, then you can do this without having any potential control on this. So if we go back to the original idea of these hardened mechanisms, they're really there to make it much more difficult for these things to happen. And this is what people are looking at right now. So with that, I'm at the end of this quick overview. Any questions?
So, Mario, I'll inject the question, and then we'll open up for the others. So did you see, so, one of the things that has worked well in other environments is the notion of sort of federated authentication, federated IDs and things like this. Did you see, so for example, one of the things that could come out of this stuff is that one is trying to avoid local clusters. So in particular environments like CERN or a particular university or a particular factory, right? That there could be local authorities that that avoid some of these issues by confirming a true positive, for example. Did you see any discussion of the federation of such entities, which would solve some of these problems, not all of them?
Not much. Most of it boils down to this part here. Who is the authority that keeps the master key? And if you have a protocol like this combined version of CEN or DP3T that works all over the world, what you can do then is that you can have your little islands where you have a master key that is valid, for example, for the area of Geneva or the area of Central Europe. And because then it doesn't matter if you run an application from Germany, if you run an application from France, because they will all use the same protocol. So eventually, you wouldn't need to do such a federated ID. All you would need to do is you would need to gain the trust of the person running the app for a given authority, because you will always need this authority even in the decentralized approach.
Okay, so I'll open it up for questions from other people.
I have a question. This is Dan Marlowe.
Yes.
So my takeaway from this is this does not look very promising. So that my own, and maybe that's unfair, but just all these problems, and this is not something that one really has a year to work out. So I wanted to go back to the sort of the old-fashioned way of doing it. And one assumption that is there that surprised me a bit is that the contact tracers have to go door to door. Couldn't they do this by email, by telephone, methods that don't involve personal contact?
In principle, yes. The only executions of this I've seen were actually people going from door to door and doing this dedicated testing.
But why did they do that? I mean, it just seems like a fantastically, setting aside the health risks, it just seems like a fantastically inefficient way of doing things.
Isn't it that the people you met, you don't necessarily know the email address of?
Well, maybe not, but you can, these systems don't have to be perfect. They only have, or to the extent that they're good, they're useful. So if a person is infected and they just give a list of names, chances are they know the people, or they know who, people who know them. I'm just thinking that it might in the end be more effective to do this in a sort of lower tech way, but aided by sort of software that web-based software where you can keep track of what's been done, and you can track people down pretty effectively.
So I would have to agree with that. The one thing that I'm still worrying about is the wrong thing. Right now, people are sharing so much of their personal life, of their private data with Google, with Facebook, and they do so without them knowing that they're doing that, but also the other half of the people are doing it willingly. Now, the thing that is puzzling me is where in these approaches that are much more secure than what they're doing already, why there is such a huge public outcry. So maybe it's just a matter of, let's say, public policy of educating the, let's say, average citizen that these approaches will help them much faster to gain back their, let's say, normal life by avoiding these massive lockdowns, by doing less or by collecting less data than what they already share. And I think this is very difficult to bring to people, but
yeah, and my worry is that it's hopeless. I mean, the level of, the level of hand wringing, to use a phrase, in your slides is just overwhelming. And my reaction to it, and look, I know nothing about this, but my reaction to it is, well, let's just give up on that. That's just so fraught with problems, and you've got lawyers, and it'll just grind to a halt. Which leads me to go back to, in terms of how the this community can make a contribution, is actually to develop software that enables these low tech means. And I come back to, I think this business, this model of people going door to door spreading infection doesn't actually, I'd be surprised if that's the way it's normally done.
I mean, that's at least what people tried in Germany and other countries, and it failed because it wasn't fast enough.
Yeah, but I would think it just seems like an odd way to go about this. I'm tempted to call our local public health officer and ask them how they do it. I can't believe they send people door to door, though.
It's clear that there's this clustering effect, right? I mean, a cruise ship is a dangerous place to be. A dorm room is a dangerous place to be, and a pork processing plant in South Dakota is a dangerous place to be, right?
Right.
And in all of those environments, you kind of know who you would have been in contact with, right? That's a sort of, independent from the technology aspects. Those things are identifiable, and they're sort of, one can follow up in the we know how to communicate with these people tracing mechanisms. I think that's why I mentioned earlier the federated aspect, because in the end, if one of us gets sick, the most likely people to get sick are our family if we're quarantined with our family, right? And the success in China, and I think also South Korea, but I'm not 100% sure, was the fact that when they had sick individuals, they even isolated them from their families, right? Because there's a clustering effect. And that's in some sense the first order problem. And then there's a second order problem, which contact tracing can enable, that you've walked into a supermarket and wandered around for an hour and a half looking for stuff that
Toilet paper.
Yeah, exactly.
So I would like to give an endorsement to federation, just because I think that with all of these, we live within circles of association, right? I think Google even had something called circles, right? And the smaller the circle, the more willing you are to trust it, right? And trust is at the key of these things, right? And as you make your circle bigger and bigger, the less and less trust you have. So if you can federate smaller trust circles, you're going to have a better success with this, I believe. And so I wouldn't necessarily give up on those things. We all know that applications like Uber and Lyft are part of the trust economy. And I use the word economy on purpose because it really is a valuable thing. This trust that we're talking about is economically valuable, right? And we have to just know that we're living in that world now and try to put together mechanisms where you don't have to have absolute central authority. It can be more of a blockchain sort of, a connection that is hard to break, That's just my thoughts on this.
I think this could work really well, yes. To give an example, such a tracing app needs to be built into the phone operating system. And it needs a way for me to select which circles I trust. So I would click on I trust CERN and I trust Saint-Genis. And then whenever I enter this area, my phone automatically negotiates with the local authority that I already said I trust and negotiates the temporary key exchange that is necessary. And as long as I'm in that area, I trust the authority and I do the contact tracing. As soon as I leave the area, I'm practically locked out of this. And then when I enter CERN, it works the same way. Then if there is a larger Swiss circle that is composed of CERN, of CSCS or whatever, then this would all start to work together. And I think this is a good approach, but as far as I know, there are no handshake protocols for this yet.
One thing that, thinking again in terms of what particle physics brings to the table, what particle physics brings to the table is the fact that we're connected to all of the major research universities in the world. And we've been connected, to these things that are sort of mini institutional. This could be a place, for example, where the academic world could come forward, especially because it has dorm rooms / cruise ships, right? To bring forward a sort of a federated protocol for these things that avoids at least some of the gotchas that you were describing. I wonder if that's an interesting avenue to pursue.
I think it is. We should go with this idea to the protocol developers.
Okay, are there questions or comments for Mario?
If I could comment again, Peter, I just posted in the chat a New York Times article, and they evidently this decision or choice between sort of high-tech ways and old-fashioned ways is an ongoing discussion. And I note that the old-fashioned people they're talking about in Massachusetts was the case at hand is done with telephone. So I may actually, I think it's probably a more realistic approach.
Well, but let's say that most people in the world are free of the virus, and there's someone who does not realize that he or she is contagious and goes to the local movie theater. And movie theaters generally don't keep track of who is there on a particular night in a particular.
Hold on. There aren't any. I mean, where are movie theaters open?
No. I'm thinking about the next 12 to 18 months before there's a vaccine.
So it's bars and sporting events.
Is that we've got three issues. One is public health, one is the economy, and one is privacy. Until there's a vaccine, these are going to be in tension. And the economy requires that people have the ability to go to movie theaters, go to grocery stores, perhaps go to classes at universities. Otherwise, the economy is in a tailspin. And so then to keep the infection rate as low as possible, I mean, there are two issues. One is the number of people who are already infected, and you have to multiply this by how quickly they can infect someone else, which depends on their physical proximity. And if you can identify people who've been in close physical proximity and get them tested quickly, so this requires both the contact tracing and the testing, then you can limit how quickly the infected population grows. And there are going to be tensions here, and they're going to be non-trivial. I think we're going, at least at the opt-in level, I think a large number of people will want this. Now, the Chinese government and the Israeli government don't need this because they have access to all the cell phone records, and they know where you are without the Bluetooth proximity. They know where you are based on the cell phone, on the cell tower information, right? And
so does that's also known in the US.
It's known to the telephone companies. The government does not have access at the moment. At the moment they would need at the moment.
Not actually sure about that. There was an article in the New York Times several weeks ago where they basically traced the location of a Secret Service agent who was guarding the president, and somehow they got that information.
So there are a lot of these commercial databases that you can buy where you have opted in to share your data with an app, and then this was done with one of these running apps a couple of years ago, where they found the perimeters of all the U.S. secret bases around the world, from the joggers who are keeping track of where they were running. and people are able to start tags, but that's from freely shared information.
So just
Sometimes you have much more detailed information. At least at the moment in the U.S., the government would need a warrant to get it.
so let me call out people. Savannah, did you want to? I see you unmuted.
Oh, I don't know. I just kind of wanted to say something, I guess, about like this original point that people are already sharing a lot of location and this kind of information with like other apps that they don't really think about. I just kind of had like two thoughts about that. It's like, one, I don't know that telling people about that is gonna make them all more willing to add a contact tracing app. I think there's at least some portion of people who would just turn off access to their location to these other apps like Facebook. Like people don't, I think like a lot of my friends like who aren't in tech, like they don't realize like Facebook is, you know, recording their data all the time. Like I showed them, Facebook already has this kind of contact tracing map up basically on their data for Good Site. That's all the Facebook locations pulled from people who have Facebook on their phone. And, you know, people don't realize that Facebook can do that already. So I'm not sure that they're going to be like, oh, everyone already knows all this stuff about me. Let's just like add another one. Like I think some people might pull back, you know, from data sharing. And then I think, I don't know, like I think this question of government, private company, like interface and data collection is actually like an important thing to think about, and part of where people's like, I don't know, unease is coming from is that, I don't know, some people like are more comfortable, you know, sharing their location with Facebook, but not as comfortable with having Facebook then like sell that to the government or like provide the government open access to that data set or different things like that, which I'm not saying is like a rational distinction necessarily, but I think like, I don't know, that these are, data privacy is like a very complicated issue, and I don't think it's like necessarily true that people are like kind of overreacting about the idea of being uneasy with contact tracing apps.
okay, Liz, you're always unmuted. Did you have another comment or just not muted?
Okay. Well, I guess the reason that what comes to mind is the reason people don't mind sharing their location with some of these apps is because they say it will be restricted to your circle of friends, right? So Snapchat has that and Facebook has that. What, of course, is implied that is that that company also has that information. That's the part that people don't, you know, don't think about when they think about, oh yeah, I want my daughters to know where I am, you know, that sort of thing. So yeah, I think so I'm just going back to my group's concept of smaller the group, the higher the trust. Okay, that's it.
So I went through, just while we were talking, I went to look at the Eduroam wiki page, and that apparently started with a task force in, of all places, Amsterdam. That, you know, this sort of federated, I mean, it's a federated trust association, right? I would be curious to see if that's, you know, maybe, you know, so we're all basically either, looking at the list of names, we're all either academic institutions or national labs, essentially. All of
And
which.
don't forget the Geneva Airport. The Geneva Airport can also use Eduroam.
You're correct. But the point being that I wonder if there could be an interesting, if they want to step up to the task, an interesting angle there that goes via the people that were originally involved in this, which presumably involves like the CIOs of the various universities. I wonder if it would be interesting to reach out to, you know, talk to them to see if there's a, because you know, as I said earlier, I think there is kind of a, you know, herd protection, avoid the local clusters element to this, that you know, potentially particular groups could step up, even though, you know, maybe people go to a sporting event or a theater or you know, a big bar, and things come in from outside. But you know, that's how it was in Singapore, that's how it was in Hong Kong, right? People went to China and, you know, South Korea, for example, but they managed then within the herd to do the appropriate tracing. So some sort of federated thing may actually be useful. There was a very interesting article which I sent around today, which is that the Dutch, was a study in the Netherlands of the blood donations, and they found that, I put this in the chat earlier, they found that 3% of the blood donations have antibodies to SARS-CoV-2.
As of when?
As of the last days, whenever they did the test. And this is, in the end, it's not inconsistent with, if you look at the testing the number of people who have died and been assigned their death cause to COVID-19 to the number of official cases. That's like 11% in the Netherlands. And that's, I think, because there's not widespread testing, because that's not how their system works, which has always been kind of anomalous. And so, you know, just based on that and some nominal expectation of, you know, 1% is maybe the mortality rate, I assume that probably the number of cases is 10 times higher, which is in the ballpark of 3% of the people being infected. So the other thing you can think about in terms of this contact tracing is at some point it's going to be, you know, not in the range of 3%, it's going to be in the range of 30%, right? So the sort of dynamics of the game changes in terms of the contact tracing when you're talking about small numbers, or you're talking about sort of the, you know, the middle ground towards herd immunity, I guess. Questions or comments from anyone else?
So I don't fully understand this issue of federated hosts or whatever. You know, but what I'm wondering is, I can imagine. So, you know, I teach at a large state university, and I can imagine that the university might want to require that anyone who comes on campus participate, we'll call it anonymously, with all the caveats, in a local app, so that if there is something that happens on campus, if someone tests positive somewhere on campus, then there will be a record. And what I thought the original apps were actually going to be much more opt-in the sense that there would be no push notifications, that a user would have to pull a notification from a database daily or however often, and only the hashtags were going to be stored. But I probably don't understand what's involved very well. Is that part of this system, or does this system require the ability to push notifications on the apps that you're using?
Mario, do you want to?
So that depends on the implementation. A couple of them have a central trust authority, and they download the list of let's say infected scrambled IDs, and then they check if they have in their local history a match. Let's say they have over 10 times they have at least 3 hits for the same ID, which practically tells them they have been in close contact with them for a prolonged amount of time. So that's, and then the app will locally flag that you have been exposed. That is one approach. The other approach is that there's a listening component, and you have then, as soon as you verify that you're infected, you can then go to a professional, like a doctor in a hospital, who can then push a notification out to the network.
But I guess what I'm trying to understand is that, so I think I understand what that means, that you know, someone who is competent or trusted is the one who pushes a notification. But then the question is, who has access to the information about which hashtags are correlated? If the only way you can get that is that you have to say, I want to see the correlations with my hashtags, does that provide an extra layer of privacy? And is that privacy that can be enforced or pardoned in some way?
That is given if you trust the third party, yes.
So if the third party is your university health service, for example, or your whichever entity you're interacting with, then in some sense you can only be identified down to the third party that the federated third party that vouched for you. Is that right, Mario?
That seems about right, yes.
Okay. Other?
I mean, this idea of federation sounds interesting to me, because I can imagine that, you know, the main campus would be one federated authority, the hospital would be another. They might have, you know, the Christ Hospital, which is down the street from University Hospital, might be another authority. And that way, if you've got people going back and forth between hospitals, they could also be tracked. But again,
there are ways to do that, right? You can put Bluetooth beacons at appropriate places, but then we would still need to develop a mechanism, a protocol to do the handshake and the key derivation from the trusted master. But that is possible, right? It's just I have not seen it anywhere mentioned.
The question in my mind is, how do you provide as much useful information while still protecting privacy at, you know, it's like the ALARA principles for radiation, right? As secure as is possible while still providing the benefits. So I think this idea of federations is good. I can easily imagine that a university where people, you know, choose to attend it, you know, no one brings you in the ambulance, you're opting to go in, that it's perfectly reasonable for a university where people live in dormitories and stuff like that to require that people have an app and, you know, check in on a regular basis in return for the privilege of attending.
I can tell you, Mike, for example, there was a case at Princeton, and the contact tracing, at least the description that I saw, was being done via the University Health Service. And Dan can correct me if I'm wrong. My understanding of how that was being done, we were sort of informed that there was something that was happening and that there would be follow-up.
Which makes complete sense.
Okay, so we are almost at an hour. So are there, especially others that maybe haven't, you know, said anything? Is there anybody that wants to ask a question or throw out an idea, that, especially among those who haven't talked?
I have a quick question. Have any of these groups sort of announced a timeline for what we might expect for rollout from their ideas or proposals?
So there's roughly 25 different apps that are already in the App Store, and a little bit less in the iOS store. So this is already rolled out. How many of those actually conform to CEN or DP3T? I don't know, because not many of them tell you how they work, which is for me an exclusion criterion. And the other ones that are on GitHub and open source are very few, maybe like 3 or 4. And those are the reference implementations. So I think right now using these apps is completely out of the question because there's not enough trust in the population. And frankly, why would you choose to run an app that is not, how do you say, that you cannot evaluate, especially with important health information. So I think what we need to do now as a community is get together and get the likes of Apple and Google on the table to make sure this is something that's built in to our everyday platforms for the next pandemic that will come around in 7-8 years.
A quick question, Mario. Are the Google and Apple apps, is the source code open source?
There are no apps. They are they only wrote a paper that describes the protocol, and they were talking about putting out the operating system APIs that are necessary to run apps in the background. So there are no apps from them directly. So I think they will build this protocol that they published in their white paper directly into the operating system.
I guess the question I'm trying to ask is whether the privacy features will be subject to external review by people who can actually read the code.
I think this is easier in the US because you have this HIPAA system for health data where you can force companies to do that. We don't have that in Europe. So I'm hopeful, but let's see. I think it's important now that we as a community go there and say, look, those are the things that you really need to be careful about and what we think is useful. And then maybe we can have a little bit of influence on the protocol, how it develops. And maybe if we can get those local trusted federated clusters into the game, because I think this is a really good idea.
Yeah, I want to go back to the connection to blockchain, right? Because with blockchain, the basis of many cryptocurrencies, we figured out how to not have so much of a central authority, right? So that's, yeah, I think that if I were more technical, I would even pursue that myself.
That is possible, yes, but with these distributed ledgers, you can trace the path, but you need to have a mechanism that makes it difficult for a new party to enter the system, which potentially means this is like mining a crypto coin. So
yeah,
you would need a phone to constantly generate, like mine new contact data for you. So
yeah, that might be too prohibitive. Yeah.
Maybe there's a smart way around this. I haven't thought about that.
Okay. Well, thank you, Mario. This was great. So useful. And thank you, everyone else. It was a useful discussion. We recorded what's up, and we'll put it up in YouTube.
And you'll post the YouTube link in the Slack channel?
I will do that.
Great.
I remind you that tomorrow we have an additional invited talk on computational biology, biomolecular simulations, and the drug discovery pursuit of drugs that can treat the virus. Any of you who have other ideas for follow-up talks, please let me know. and everyone have a nice afternoon or evening, depending on where you are, and more soon. Thanks, everybody.
Thank you.
Thanks,
Bye-bye.
bye.
Mario, thanks very much. It was an excellent talk.
Thanks.
Yep, pleasure. Bye-bye.